All right, here we are, the last submitted assignment. You've made it. All I need you to do is submit this. When you do, await your final grade for the fourth marking period. Remember, as long as you participated, you'll get a grade. It'll be matched by whatever you got in the third marking period. This is everything about Chapter 7. You see a stem and leaf plot. Hopefully you're doing this on the Google Drive assignment and you can see this a whole lot easier. It's cut off in a couple of places for me, but information is all the same. It represents the Philadelphia 76ers regular wins totals from the 17 years leading up to Ben Simmons' rookie season. What is the mean amount of wins during those years? Well, you know that there are 17 numbers here represented by the stem and leaf plot. One way to do it would be to add all of those numbers up. Divide by 17, and you get that the mean, also known as the average, was 34.65 if you round, and so you could say about 35 wins. This, of course, is the accurate answer. This would be the answer that makes sense based on basketball. You don't win 0.65 of a game. What was the median? Remember how you can find the median, stem and leaf plot. It's organized, smallest, biggest, and you just start to count. Counted 8 on this side, 8 on that side. There's the middle number, also 35 wins. Over the last 17 years, how many seasons did the Sixers have win totals in the 40s? 1, 2, 3, 4, 5, 6. You can see them. So they had 6 different seasons where they had wins of 40s. The NBA season, and I threw this in here in case some of you aren't basketball fans, has 82 games in length. What was the percentage of wins by the Sixers in their best season? All right, best season, they won 56 out of 82, which means they won 0.68. They won about 68% of their games. Not bad. In their worst season, 10 out of 82, they won about 12% of their games. Not good. All right, moving on. Use the box and whisker plot to answer the questions below. This box and whisker plot is the same information as the stem and leaf plot. What is the interquartile range? Remember, IQR is Q3 minus Q1. Q3 is at 42 minus Q1 looks to be in between 27 and 28. Let's call it 27 and a half. 42 minus 27 and a half, 0.5 would make it 28, 14.5. If we replace the horrible 10-win season with 50 wins, we get rid of this and replace it with a big number. What would the mean increase or decrease? Well, since 10 is less than, and remember the mean was about 35, since 10 is less than 35, if I remove that 10, that means instead of that 10 pulling the mean down, it's actually going to let it move up a little bit more. And then now when I add a 50 in instead, that's going to increase for sure. That would pull the mean up. Would the same change happen to the median? Yes, definitely. The median would also move up. Now it might not move up as much, but it will definitely move up. based on the box and whisker plot, what is the chance the 76ers had a season better than 42 wins? Well, here's 42, right? Q3. Better than that would be anything over here. That's 25%. Remember, box and whisker plots always split up by 25%. All right, now we got a couple of questions on a scatter plot. What correlation does this show? Remember, our correlation of scatter plots are positive, negative, and none. Now, what's nice is you can already see there's a line of best fit shown for you. Definitely negative. It's going down. That means as one of these things goes up, let's look at this one. As the time goes up, as we start to get more and more years, the value goes down. Anyone who knows anything about cars knows that that makes sense. And really, it's not cars specifically. It's a lot of appliances and goods, industrial goods that over time they get older and they don't work as well. As a car gets older, its value is going to go down. Okay. Name 2 points that are on the line of best fit. So, when you look at this, here's one for sure, right there. So that's like, let's call it 7.3, comma, that's right in the middle, 5.5. If you're watching this and you have something close to that, you're good to go. Here's another one close. I think this one's better on the line, so I'm going to use that one. Let's call that like 11.2, comma, that's a little bit more than half. Let's go 2.6. That's one. If you use that one, that would have worked. The other thing you could have done is something like this. It's not a point that's part of our scatter plot, but it's definitely a point that's on the line. 8.5. It's a really nice point. You would say that that's on the line. Same thing happens down here. Okay, that point. It's not part of the scatter plot, but it is part of the line. That would be 12.2. That's definitely on the line. Lots of different answers. What would you predict the car value is of a car that's 8 years old? Okay, well, here we go. 8 years old. Follow it up to the line. Anytime you want to predict, you're going to use the line. Follow it over. This is in thousands of dollars. 8 years old, $5,000. All right, we've got just our probability questions left. 3 questions. All deal with 3 different fair things, and the only reason I wrote fair there is just to eliminate any like stupid bias questions like well, what happens if the dice is loaded, or if the coin is double-sided, things like that. Okay, fair coin, fair dice, and a spinner has 15 equal sides. What is the probability that you flip the coin on tails? Tails, you have a 50% chance, 1 out of 2. And, remember, and in probability means to multiply an odd number. Odd numbers, 1, 3, 5, 7, 9, 11, 13, 15. I'm hoping you did the same thing I did because it's not actually 50%. 1, 2, 3, 4, 5, 6, 7, 8 out of 15. A little bit higher than 50% actually. All right, here's how I like to deal with fractions, and you may have seen this on my last submitted assignment. I cross multiply. That turns into a 1, that turns into a 4. 1 times 4 is 4. 1 times 15 is 15. 4 out of 15 would be about 27%. Okay, it actually comes out to 26.67. We could round that up to 27%. What is the probability of the spinner getting a number less than 5? 1, 2, 3, 4. Or, remember, probability or means to add, greater than 10. 11, 12, 13, 14, 15. Okay, so there are 5 numbers greater than 10. There are 4 numbers less than 5. Okay, the key words here are less than and greater than. Not less than or equal to, not at least 5, nothing like that. Less than 5. There are 4 numbers less than 5. 0 is not on the spinner. So we have 4 plus 5 means we have a total of 9 out of 15. Well, that's going to reduce to 3 out of 5, which is about 60%. Last one. What is the probability of rolling a 6? All right, well, that's 1 out of 6 sides on the dice. And flipping a head, so that's 1 out of 2 sides. And spinning a 6. That's 1 out of 15 equal slices. This doesn't look good. 1 out of 2 times 15 is 30, times 6 is 180. So you should expect that to happen 1 out of every 180 tries. It's equivalent to 0.0056, which is the same as 0.5%. Not even a 1% chance. 0.5% chance that you do that. Like I said, last submitted assignment. You are completely done. Okay? Have a good summer. Thanks for doing what you're supposed to. If you haven't done everything yet, you still have time. You have until June 1st. You don't get it done by June 1st, I can't give you credit for it. Unfortunately, I have a bad feeling I am going to see some of you in Algebra 1 again next year. Tell your friends, tell anyone you know they've got to participate, or we will be seeing some of you in Algebra 1 again. Those who have done what they're doing, awesome job. Have a good summer. See you next year.